In this, our second FOA video about networks, we want to talk about network architectures, how the devices are physically connected in the network. In our first video, we showed you the type of users that we're talking about connecting on our network. End users using either wireless or wired connections, connecting to each other, to servers, storage, and the rest of the world on the internet. The network needs to have an architecture that can accommodate large numbers of users. As we show here, users that are connected wirelessly to a Wi-Fi access point want to connect into the wired unit to share connections with wired users on multiple levels and eventually into a central switching point that can connect them to servers and storage and the internet. In order to do this, we must have switches or equipment that can connect everything and provide, as we show in this slide, higher amounts of bandwidth as we accommodate more and more users and get closer to the center of the network. Here we're showing the tree and branch structure, but we want to look at other ways that networks have been configured in the past and are to some extent still being used today. We talk most about star networks because they're the most common. It's the way telephone systems and most LANs commonly in use work, where there is a central hub or a switch and computers or phones or wireless access points or whatever connect into the network. But there are other types of networks that have been used and are still in use, including the bus network, a ring network, and a mesh network. So let's look at them. Ethernet was originally designed to use a coaxial cable, and literally each connected device tapped into the cable physically, with a device that was sometimes known as a vampire tap, but officially known as an AUI, or Attachment Unit Interface. A bus network means that all users are listening to all the data transmitted. So in order to allow access to the network, some unique protocols were developed, which we'll talk about in our next video. Ethernet developed from a large, thick coaxial cable to a thinner coaxial cable and eventually to twisted pair in a star network. A ring network connects all the devices on a ring, as shown in this diagram here from Fiber Distributed Data Interface, FDDI, the first all-fiber network developed around 1990. IBM also used the ring architecture on their token ring network, which used shielded twisted pair copper cables. The data travels in one direction on the ring, and each station is a repeater. By using a dual counter-rotating ring for redundancy, you can build a network that will survive the loss of a station or a link. A mesh network is like the internet or the phone system, where the switches have connections to multiple other switches. That provides redundant paths for more reliable connectivity. In the phone system, it means you're much less likely to get a circuit busy. And in the internet, it means that you can almost always get from point A to point B but you don't quite know what the path is going to be. Optical LANs, based on fiber to the home passive optical network technology, work very similar to a star switched network, except for the fact that one of the switches is replaced by an optical splitter. The optical splitter works as a splitter going downstream to the users and a combiner going upstream to the optical line terminal, the central switch in the system. FOA has a very good video on fiber to the home and optical LANs, either of which you can use to learn more about this particular architecture. The big advantage comes from the passive implementation and the unique way that it shares bandwidth, which we'll talk about in the next video. Once you've connected all these devices, you then have to figure out traffic control. You have to figure out how to allocate the bandwidth in the network, and you have to figure out how to ensure that every device gets a chance to transmit the data it wants to transmit. So in our next video, we'll talk about allocating bandwidth in a network. We're the Fiber Optic Association, the Professional Society of Fiber Optics. This is lecture number 2 in our multi-part series on how networks work. For more information, go to the FOA website and look for our online guide to fiber optics and premises cabling.